Hi everyone, I am Dr. P. Kalpana. Welcome to my channel. In this video I am going to teach you how to find the minor of an element, cofactor of an element and determinant of a 3 by 3 matrix. So let us consider a matrix A. A equals to A1, B1, C1, A2, B2, C2, A3, B3, C3. So here A1, B1, C1, A2, B2, C2, A3, B3, C3 are the elements. To find the minor of an element, what we have to do is just delete the rows and columns of an element in which we have to find the minor, and the determinant obtained after deleting these rows and columns will get the minor of an element. So the minor of an element is defined as the 2 by 2 matrix, the determinant of the 2 by 2 matrix obtained after deleting the rows and columns in which the element is present. So that is called as the minor of the element. So A1 equals to, so the minor of the A1 is, if you delete the row, this row and this row, this column, so A1 equals to the determinant. The determinant is B2 C3 minus B3 C2. So this is the minor of an element. Now coming to the cofactor of an element. So cofactor of an element in the ith row and jth column is defined as the minor multiplied by -1 whole power I plus j. So that gives the cofactor. So cofactor of an element equals to -1 into I plus j into its minor. So that gives the cofactor of an element. If you take A1 cofactor, cofactor of an element A1 is, so -1 into I plus j. So what is I? I is a row number. So A1 is present in the first row. So I is 1 and j, the column also number 1. So 1 plus 1 minus 1 into its minor. So minor, what is a minor? Minor is after deleting the rows and columns in which the element present and the determinant. So B2 C3 minus B3 C2. So this gives the cofactor of an element. Now coming to the determinant. So determinant of a 3 by 3 matrix is defined as the sum of the product of elements of the first row with their corresponding cofactors. Is called as the determinant. So if you take the determinant of the given matrix, so first the sum of the product of the elements of first row. What are the elements present in this matrix? First row elements A1, B1, C1. So first the product of A1 with their corresponding cofactor. So corresponding cofactor is, A1 cofactor is -1 whole power 1 plus 1, because I is 1 and j is 1, and B2 C3 minus B3 C2. B2 C3, the determinant B2 C3 minus B3 C2 plus, and B1 into the cofactor of B1. So to find the cofactor of the B1, what we have to do is just delete the columns and rows in which B1 is present and find the determinant. So the determinant of A2, C2 and A3, C3. A2, C2 and A3, C3 is A2, C3 minus A3, C2 and minus 1 whole power I plus j. What is I here? I is 1 because it is the first row. 1 plus j. J is second column. So B is present in the second column. So j value is 2. So this is minus 1 whole power 3 plus third, sorry, this is B1. A1, B1 and third element is C1. So C1 into minus 1 whole power I plus j. So I is first row and j is third column. And what is a minor? Just delete the first row and the third column and find the determinant. So the determinant is A2 B3 minus A3 B2. A3 B2. So this is the determinant of the given 3 by 3 matrix. Find the minor and cofactors of all the elements in the matrix A equals to 1, 0, minus 2, 3, minus 1, 2, 4, 5, 6 and also find the determinant of A. So first write down the given matrix. A is 1, 0, minus 2, 3, minus 1, 2, 4, 5, 6. So this is A. Now compute a table. So elements, write first elements. So what are the elements? 1, 0, minus 2, 3, minus 1, 2, 4, 5 and 6. So next I values and j values. So I value. So I, the first row, this is one element 1, I value is 1 and j value is also 1. And next coming to the 0. So I is 1 because it is present in the first row and j is 2, second column, and minus 2. I is 1 and j is 3. And third, number 3, element 3, I value is 2 because it is the second row. 3 minus 1, 2. So these are second row elements. And 3 is the first column and second column and third column. And this is third row. 4, 5, 6 are third row. And this is 1, 2, 3. Now write the 2 by 2 matrix. The 2 by 2 matrix, for 1, the 2 by 2 matrix is deleting the row and the column. So minus 1, 2, 5, 6. And for 0, delete the first row and the middle column. So 3, 2, 4, 6. And minus 2. For minus 2, just delete this column and this row. So 3 minus 1, 4, 5. 3 minus 1, 4, 5. And for third one, just delete this row and this column. So 0 minus 2, 5, 6. 0, minus 2, 5, 6. Next for 1, minus 1. For minus 1, just delete this row and this column. So 1 minus 2, 4, 6. 1 minus 2, 4, 6. Next, second. So delete this row and this column. So 1, 0, 4, 5. 1, 0, 4, 5. Next, 4, 3. Sorry, 4. Fourth element, just delete this row and this column. So this row and this column. So 0, minus 2, minus 1, 2. 0, minus 2, minus 1, 2. And for element 5, delete the middle column and the last row. So 1 minus 2, 3, 2. 1 minus 2, 3, 2. And 6th, delete this column and this row. So 1, 0, 3 minus 1. 1, 0, 3 minus 1. So now find the determinant of 2 by 2 matrix. Then cofactors. So these are the determinant of the 2 by 2 matrix is the minor of the element, and the cofactor matrix is minus 1 whole power I plus j into its determinant. So first the determinant of the first element is, this is 6 minus 6 minus 6 plus, sorry, minus 6 minus 10. So minus 16, and this is 3, 6, 18 minus 4, 2, 8. 18 minus 8, 10, and this is 3, 5, 15, minus into minus plus 4. So 19, and this is 0 plus 10. 10 and 6 plus 8, 14, and this is 5 minus 0. 5, 0, minus 2. Minus 2, and 1 minus 1, 2, 2 plus 6, 8, and minus 1 plus 0, minus 1. So these are the determinants. So the determinants of the 2 by 2 matrix is nothing but the minor of the each element. And coming to the cofactor of the element, so minus 1 into I plus j. So here I plus j is 1 plus 1. So 1 plus 1, 2. So minus 1 whole square. Minus 1 whole square is positive value. So this is cofactor is the minus 16. And for the second one, minus, for the 0 element 0, this is minus 1 whole 1 plus 2. 1 plus 2 means 3. So that is, and determinant is 10. So minus 10. And for third one, minus 1 into 1 plus 3. 1 plus 3 into 19. So that is, this is 4. So positive value plus 19. And next, minus 1 into 2 plus 1. 3 into 10. So minus 10. And for minus 1, this is minus 1 into 2 plus 2. 2 plus 2, 4 into 14. So 14. And this is minus 1 into 2 plus 3. So that is 5 into 5. So minus 5 and minus 1 into 3 plus 1 into minus 2. So minus 2, and this is 3 plus 2. Minus 1 into 3 plus 2 into 8. 3 plus 2, 5. So 5 minus 1 whole power 5 is minus value. So minus 8. And the last one, so minus 1 into 3 plus 3, that is 6 into minus 1. So minus 1. So these are the cofactors. Now coming to the determinant of A, that is 3 by 3 matrix, is the sum of the product of first row elements with their corresponding cofactors. That gives the determinant of A. So the first row element, first element is 1 into its corresponding cofactor. What is the cofactor of 1? 1 is minus 16 plus the second value. So 0, second element is 0 and its cofactor is minus 10 into minus 10 plus third element. Third element is minus 2 into its cofactor 19. So minus 16 plus 0 minus 38. So minus 54. So the determinant of the given matrix is minus 54.
If you feel this video is informative, please like, share and subscribe my channel. Click the bell icon for quick updates.